Hello guys, today we are going to see structural analysis of PS Stent using COMSOL software. So this is the PS Stent design which we have made in SolidWorks. So this is the standard design. And so for dimension of the design we have taken from some research paper, and for material we have used polycaprolactone. So the material properties of polycaprolactone is like Young's model is 0.3 GPa, Poisson ratio is 0.3, and density is 1140 kg per meter cube. So as we know that if we want to perform any simulation like analysis of any particular design on software, so for that we need boundary conditions. So in this case, what are the boundary conditions we are going to use? That are these. So we are taking inner boundary load as 14 and 16 atm, and we are taking outer load 780 kilopascal, which is actually causes by the plaque. And for fixed constraint we are just selecting the all end faces of the stent. So as I mentioned earlier that we are going to use material property of the PCL. So this is the mesh geometry. We have just used extremely fine meshing for the stent. So after following these all things, we have just computed the results and got these surface plots for von Mises stress at 14 atm and at 16 atm. So at 14 atm we got 1.8 into 10 to the power 9 Newton per meter cube von Mises stress, and at 16 atm we got 2.51 into 10 to the power 9 Newton per meter square von Mises stress. So now we are going to perform this simulation into the COMSOL software. So this is the stent design as you can see here, which we have imported. And in the global definition, just click on the parameter section and define the inner load and the outer load. So we are just taking inner load as 14 atm, which we have like already mentioned, and outer load is 780 kilopascal. And then we just click on the linear elastic material property, and in which we are going to select a stent. Okay, so for that we are going to give the properties of the polycaprolactone. So as you can see here, so we have given the Young's modulus, Poisson ratio, density. So for selecting the stent we have to just click here and we have to just select the stent as you can see, and then by right clicking on the solid mechanics we will click on the boundary load. Okay, so we have there as you can see here. So for boundary load we have just selected the inner part of the stent because it is inner boundary load. So as you can see here we have just selected the inner part of the stent, and then we again click on the boundary load. So in this boundary load too we have just selected the outer part of the stent as you can see here. Okay, and for the fixed constraint we have selected the end faces as you can see here, this and this. Okay, so like we have just followed all the conditions which we have mentioned earlier. So now in the meshing we have just selected the extremely fine and clicked on build all. Then we got this meshing. This is not looking good now. Yeah, this is good now. So as you can see here, this is the meshing of a stent. Okay, and then we have just clicked the compute in the study section and got the von Mises stress as you can see here. This is for 14 atm inner load. So the maximum value is 1.8 into 10 to the power 9. Now we are going to perform for 16 atm. So for that we have to just change the value in the parameter. Just type here 16 atm and then go in the study section and then click on compute. So it will take some time to compute. So now we got the one message test plot for 16 atm inner load. So the maximum value is 2.51 into 10 to the power 9 Newton per meter square. Okay, yeah.